Hello, everyone. My name's Josh. Hi, Paul. So, welcome to the last slot of OSCON. I'm sure you've all had a great conference. I certainly have. It's been a lot of fun. And anyway, I'm here to talk about an experiment that I've been coding up in my spare time. So, first, a little bit about me. I work at Google in Australia. So it's been interesting when I come to the US because I see all these people at conference who are supposedly my colleagues, and I've never met any of them before. They're all lovely people, so it's fine. Yeah, and anyway, this is something as I just mentioned, I've been working on in my spare time. It's still in a fairly experimental state. It's not in any way an official Google product, but all the source code is up there. I'd really love it if you had a look. And this is a live coding talk, so I promise there's only 3 slides. Here's slide number 2, and slide number 3 is what I'll show you when the thing's over. Okay, so slides is over. I'm going to sit down here. So, I was playing a computer game one day, and the name of this particular computer game was called Shenzhen Go. It's by a company called Zachtronics. You can buy this game on Steam, and it's available for Windows, Mac, Linux, and you get the idea. What made this game very addictive to me was the fact that it was a programming puzzle game. What does that mean? Well, you write programs to solve puzzles. And in the particular case of Shenzhen Go, you put little virtual microcontrollers on a circuit board, wire them up, and then program each one to solve the problem. And what I found very cool about it is the whole sort of emergent behavior you get when you have fairly simple pieces interacting with one another in order to solve a complex problem. I liked this game very much, and I honestly can't stop spruiking Zachtronics games enough. They've just pre-announced a game called Exapunks, which I think you should all pre-order as soon as possible. It looks very cool. But I thought that if it wasn't a puzzle game, what would it be? What would the language be? Would it be the same sort of very basic CPU assembly code style? Would all my programs be forced to fit in 9 or 14 lines of code? It seemed a bit unreasonable. So I thought, what if we replace the language with Go? So I'm just going to blow this up a bit so that you can read it. So I started implementing it. And then that was about October 2016, and I did a first release, which I spoke about at LinuxConf AU 2017. Since then, I've been chipping away at it. I'm not a language expert. I have not written a computer programming language of my own or even written a compiler for an existing language of my own. So this is kind of novel for me. But what made it really easy is that I've been able to wrap lots of bits and pieces from the Go toolchain and the Go compiler and have something working. Okay, so I promised in the abstract that I'd be writing a server today. So I may as well get started. Let's just create a new file. Let's call it server. I've just, and keep in mind that I've also written the UI here, so it's, I've been throwing lots of patches at it over the last week, so it's, another question, is this actually readable? If it's fine, then I'm just going to leave it. I basically implemented theming yesterday. So, because I came in here and I noticed that the projectors are a little washed out, so I implemented like a dark mode. Okay, so it's fine. It's fine. If the audience is fine with it, then we're fine. Okay, so I'm just going to give this a name. I'm just going to call it server, and it's got a package path of OSCON 2018/server. This is where it's going to generate some Go code that actually implements the program I'm about to write. And I'm going to tick it as a command. It doesn't really matter at this stage whether or not. So on the left, we've got this sort of blank gray area here. That's where the program's going to go. And on the right is the editor for whatever's selected. In this case, nothing selected, so the whole thing has got this editor. So, okay, and what does this program look like if we just turn it into some Go already? So on the right now, we have a preview of the Go that it's generated. It generates a package line. It generates a comment before it. It generates some imports. It then has a fairly sparse-looking func main. This basically does nothing. It does nothing with a small amount of overhead as well. All right. So, all right. Let's go and create a server now. Boom, done. I've implemented a server. And you're thinking, wait, what sort of joker is this guy? Is he gonna like actually do some code at some point? Yes, I will be getting into some what you might traditionally call code. But I feel it's worth shouting out to sort of a visual approach where you wire a bunch of boxes together, because you can do some pretty surprising and sophisticated things even in a visual environment like Scratch. The difference with what I've implemented though is that, well, to give you an example, I went to the Godot tutorial that Paris and John and my friends ran the other day, and they briefly showed a picture of the visual scripting editor that comes in Godot. And the thing that surprised me is that, like a lot of other visual systems, it has very basic nodes that do some very basic things for you. So for instance, if you want to multiply two numbers together, you can drag on a little multiplication node, and then you can drag one line in for the first number and a second line in for the second number, and then you get your output from the, and by the time I've finished explaining this, you're probably thinking, just let me type an asterisk. Right, so my approach is trying to blend some of these prefabricated components, like a HTTP server here. This has some bits in it that opens the network socket, listens for HTTP connections, and marry that with bring your own code. So let me type some code somewhere that does what I want it to do. So I did lie that when I said that this was a complete server. It's not. First off, I need to actually send it a little bit of configuration. And to do that, I'm just going to use a completely generic component that I've got called code, and it's going to be, send some config, right? And in the actual, I'm going to declare like an output for it. I'm planning on improving this experience. Right now, I'm like handwriting the JSON that defines the interface for this part. But once it's done, we can drag it around. It'll have like little dots where you can connect lines and so on. So let's call it config, and we're going to give it a direction. So these little pins on the top and the bottom are like correspond to inputs and outputs. So I'm going to call this an output, and I'm going to give it a type, which is just going to be a special type that I've got predefined called parts.http server manager. Cool, and there it appears, and so I can see that these two pins here, like the one that I just invented and the one on the top of the HTTP server, have the same type, so I can connect them up. Boop. There we go. It's invented a name for this channel, which brings me to what's actually going on under the hood, because now we've got some nodes under on the canvas here. We can see that it's well, okay. There's a bit of an error there, but I'll fix that in a second. So that's this wouldn't be live code without something going wrong with it. It's weird. I'm going to save it. Maybe it doesn't know about parts. Oh, God. Oh, right. Pointer versus not pointer, right. Okay, now this should work. Okay. Yeah. So back on the right, we have the generated code. Now it's got something a little bit more happening on. I'll start down the bottom in the main function. So there's this channel 0 that corresponds to the line that I dragged between the two pins. And then it has this wait group that it had before, and it runs a couple of Go routines, and when they're done, it waits for them to finish. Pretty easy. The two Go routines, the first one spins up the server, the second one spins up send some config. And send some config I haven't implemented yet, so it's empty. But the HTTP server's got like a little bit of a wrapper around the inbuilt HTTP server type. So pretty straightforward. If you've used Go's HTTP server, you should know what to expect there. Now let's just very quickly send off some. So I'd call this thing config. So I'm going to write config, and I'm going to send out of the config pin a new HTTP server manager. And the reason I send in the config at runtime rather than just sort of configure it in the editor is because the config for a HTTP servers in productions, you're going to vary by like when and how you run it. It's going to vary according to some external config. Maybe it's got a different port number that you want to listen to depending on like which copy of this process you're running. So I'm just going to give it kind of a static looking listen on any interface and on port 8765. And if we preview that, we now see that we have here that code has appeared there, and it's wrapped it in a defer just because of where I put it in the part of the code called tail. But if I put it somewhere else, like I say, moved it to head, it doesn't wrap it that way. This is the part of the model that I've come up with, and I'm only 60% sold on it. But the basic idea is that you have a head and a body and a tail, and you can run multiple copies of the body, and the head and the tail are there to give you that sort of setup and cleanup for all of the copies that you have. So if I wanted to say send like 3 copies of that message, I could put 3 in the multiplicity here, and then that changes the name to x3, or I can make 5 or 100,000, and this would waste a whole bunch of CPU and then die. We only need to send it once, so I'm just going to leave it as 1. Okay, so we're nearly there for the HTTP server. The thing I haven't implemented yet is, how is it going to handle the response? What should we send back? And so we have a couple of outputs here. I have errors and I have requests. And requests is what we're going to handle first. So rather than just using a general sort of code part, I'm going to dump on it what I've called a transform. And the transform doesn't have to be connected out the bottom, so it's kind of like a for each. So for each request that it gets, it's going to do something. And it's configurable type, so I can say configure it to accept a parts.http request. And it doesn't matter what type we give the output, so I can just leave it as $any out. And we need to do some HTTP stuff, so I'm just going to use net HTTP. And then for every input that we get, I'm going to write some output. So part of the deal with transform here is you get a value called input. This is whatever it's just read off its input. And it'll keep reading inputs and trying to process them until the channel is closed. So we have here input.write, and I'm just going to write something like hello HTTP. New line. Yeah, that should be enough. So if you've written a Go HTTP server before, you may be wondering just how this is supposed to work in another Go routine separate to the one that's actually associated with the network connection. The HTTP request type that I've wrapped the request in has to be closed in order for it to return back to the HTTP handler. So in addition to saying input.write, I'm going to say input.close. Cool. And now, if I preview that, just to make sure it works, yep, so there's the code. We can see there that for every input, it's going to write hello HTTP and then close. Cool. Now, let's save that just to be sure and run it. Oh, no such file or directory. Maybe I need to manually make that directory. Hang on. Just fix this up. So cd go source, OSCON 2018. This does have some rough edges on it still. So, okay, so all right, and it doesn't understand what context is. Cool. So I'll just import context somewhere so that it will compile. Save, run. What did I not used? Did I do that right? Live coding, it's, you know. Yeah. Is it still there? Yeah, it's still there. Must be pulled in for some reason. Yeah, okay, I'll just use it somewhere. Because you can do that. You can do this, you know, context stuff to do. I'll look into why that's happening later. Okay, so it's running. It doesn't output anything because this isn't like an interactive console thing. But I should be able to like open up a new thing and go localhost 8765, and you see there. Cool. Now, that's a pretty boring server. I thought I would actually do something a little more interesting. So I'm just going to change the name of this to generate Mandelbrot. And this is going to be a little bit more involved. So we're going to need bytes and image color. And image PNG, and we're going to need some complex math. We've got NetHTTP in there. I'm going to stick time in there, and yeah, that's fine for now. Cool. So, what does this thing do? Well, instead of doing that, I'm going to first defer input to close, so I don't have to remember to do that later on. Now, well, how big should it be? Let's say width of 640 and a height of 480. And let's say we'll go to an iteration depth of 30. Now, we need an image, and it's going to be an image.new RGBA. And that function takes a image.rect. And it's going to be width W and height H. Pixels. Cool. Now, the actual Mandelbrot bit, for I is 0, I is less than W, I++. Unlike Swift, which we just had a session about, Go still has a more traditional sort of C-looking for loop. But also unlike Swift, all the different kinds of loop, actually unlike a lot of languages, all the different kinds of loop are called for. So your while loop is called for, and your, anyway. So for j is 0, we're just looping over all the pixel coordinates here. So j, h, j, yeah, less than the height. Okay, so we need to deal with complex numbers. So I'm going to have a c, which is a complex. And because you need to cast everything explicitly, I'm going to do that here as necessary. So I have to convert them to floats and then put them in a complex number rather than just assuming assuming you can do it. I'm going to scale it by the width. And you notice that W is a const which is defined to be 640, but 640 looks like an integer, but really it's any untyped integer constant, because that's Go. So I can just define it by W, and it's going to realize, oh, that works as a complex number. It doesn't work for the variables I and j because they're explicitly ints at this point. We're going to multiply by 4, and we're going to subtract a complex constant. Is that going to work? 1.5i? Yeah, that should be fine. And I'm going to define another one called z. Cool. If I just save that and preview, yeah, it's going to have some errors. All right. It's got an error on line 40 in the actual output, so I've got a preview without Go format. And I'll see on line 40 that I've got a colon that I've typed there, so I'm just going to fix that up. So this should preview but not compile because I've got unused variables, which is fine. So what I'm going to do with Z, well, I need one more variable actually. I'm going to call it col for color. Color.black is what it's going to start with, and then I'm going to have yet another loop. This is going to do the work. I really can't type colon and semicolon at the moment. All right, K starts at 0. K is less than, goes until the depth that we've defined. And finally, it also goes up by 1 each time. And then we have the Mandelbrot magic, Z equals Z squared plus C. It's so much easier than having to do the real part and the imaginary part, and then the last part of the Mandelbrot magic is to say, well, if the number is outside the escape radius, then we basically color the pixel differently. So color equals color dot white, and break. Break out of this innermost for loop, not the outer one. And then once we're done with that, we can set the pixel value ij col. Cool, so now we have the image sitting there in an image, and we just need to render it back to the user somehow. So I'm going to use bytes to create a buffer. I'm going to use PNG to encode into that buffer. I'm not checking the error there because all writes to a bytes.buffer succeed, but if you're writing a real program, you'd probably go, oh yeah, he's missing an error check there. And once we've got it in bytes, we can serve it. So http.serve content. I like using the serve content function because it handles things like range requests and other like preconditions for you. Now the input wraps the response writer and the request for you. The third argument is a name, and it doesn't matter, but what it does is it looks at the extension of the name and then uses that for the content type. So I'm just going to call it mb.png. The fourth argument is when the resource was what its time, so I'm just going to pretend that it was created right now, because it sort of was, and then the actual content. So I'm just going to use bytes again, but I'm going to wrap the content in a reader because the content has to satisfy the read-seeker interface. And regular bytes buffer doesn't do that. Bytes.newReader does. So bytes. Okay, so new reader, close parenthesis on that, and then close parenthesis on serve content. And we should be done. All right, let's save that. I'm just going to run install. Okay, so it built and installed correctly. That's great. I'm going to run it. Again, no output because there's nothing there. But if I go over to a new tab and I once again go over there, oh, no. Ooh, that's a good point. PSAU, do I have something running? Yeah, I think I've got something running there. So you get another sharp edge. So right now it doesn't automatically kill the process when anyway. I said this was experimental, right? All right, we'll run one more time and we'll go back to this tab and we'll refresh. Hey, there it is. So far I've implemented a fairly slow server because what this is going to do is it's basically serialized, calls to this generator Mandelbrot thing. It's only running one instance of this. So what I could do, for instance, if I wanted to say run 2 of those or 4 of those, that would be pretty sensible. Now I have 4 Mandelbrot generators listening for requests. And that would be, that would give me a little bit of a speed up. So as long as I can keep running concurrent processes, I can keep generating Mandelbrots. Maybe I don't necessarily know what server I'm going to be running on, though. And Go has this function called runtime.numCPU, which tells you how many CPU cores are available. So the other week, I thought, oh, it would be nice if I could just have it understand what n means. And so it does. This now translates into a call.runtime.numCPU in the behind the scenes. Sweet. So now it'll generate Mandelbrots as fast as it can. Except we can do better, because the Mandelbrot fractal is highly cacheable content. It doesn't actually change between requests, at least not the one that I've defined here. I could parameterize it, let the user browse for like different coordinates, but even then, you know, the response for a particular set of parameters isn't going to change. So let's introduce a cache. I'm just going to delete that channel. And I'm going to add a cache. And the cache has got a couple of inputs. It's got get and put, and it's got hit and miss. Unfortunately, I can't just use the cache off the bat right there. It's built so that it can work with anything. And if you know Go, you may be wondering how I've managed to build a function that works with anything. The answer is last week I added generics. Go famously does not have generics yet. I'm assured through the grapevine that the Go team are still looking at how they might add generics to Go. For now, they don't have generics. And it's also true that I haven't quite implemented generics. I've just implemented functions with type parameters, which gets us most of the way. So here I have a cache, and it lets me get things, and the get requests have to be of the type, they're going to be a struct, and the struct's got to have a key in it and a context in it, and those two types can vary. The key can, at this stage, be anything, and so can the context. The context is there to track a request, so after I get something out of the cache, I can then respond to the same request rather than having to track it some other way. Because that struct type is not the same as the requests coming out of the server, I need something to transform them. Oh, it's a good thing I have a kind of a component that'll let me do that. So let's just transform. And the thing is, this syntax here, this $sign thing that I've introduced here, will work in the generic way as well. So any in here is going to be inferred to be a parts.http request, and the output is going to be inferred to be a struct with some key in it. Unfortunately, that's where the inference ends because it won't know what to fill in for key and context. So I've got to give it a more specific type here. I'm going to say key is going to be, well, we're only generating one Mandelbrot, so it may as well be empty struct. And the context is going to be the original requests. Cool. So I'm just going to write to outputs. Unfortunately, this is where it gets a little bit verbose because I have to then go I have to declare the type inline and then fill it in. Actually, because the zero value for an empty struct is just the empty struct, I don't need to put that one in, but I can put the context to be the input. And that should be enough for that. On this side, we've got hit and miss. When we hit, we want to just serve the content. When we miss, we actually want to go and generate a Mandelbrot. So you may notice that these blocks are connected via links in kind of like a chain. I thought about calling this kind of programming blockchain programming, but turns out that was already taken. Something else you may be thinking is like a cache. Can't he just run up like a memcached or something? Well, memcached smells a lot like microservices, and this is all running in a single binary, so boom, nanoservices. All right, back on with the show. So every time we miss, we want to generate a Mandelbrot, and every time we generate a Mandelbrot, we want to put it in the cache. So now we've got this little crisscross pattern. Again, another edge I want to sort of shave off the side of this is to actually have the the channels like route around the parts and have like little right angle connectors with make it look a little bit more like a circuit. But for now, they just go in straight lines. Generator Mandelbrot, though, is still expecting, it's still expecting HTTP requests. So what I'm going to do is I'm going to say, well, if it misses, it misses the same time as the same type as the get. So I can just copy this type I've previously created here, and I can dump it in there. And then when we put, it expects a structure with a key in it, but also some data. So I'm going to just twiddle it straight away. Okay, so that's the type setup. All the imports are the same. Now, instead of serving, I'm just going to get rid of that. And we're going to send on the outputs. Key doesn't, key, yep, struct, data, byte. And I'm going to fill in that data with the buffer. Yeah. Cool. So that gives us getting, putting, and missing. And actually, we want to serve it as well, now that I think about it. So I'm just going to leave that in there, that serve content call. Because that'll save us having to do another trip through the cache just to get it the value that we put in. And then finally with hit, well, that is kind of like a composite of keys, context, and data. So I'm just going to add one more part for that. Whoop. I'm going to copy that. It should infer it, but and back in here, I'm going to steal that serve content call. Serve content. Oh. And we're just going to serve the data, and then close. Cool. So now, does this work? Oh, it's got lots of stuff in it. Okay, so we can't just close input because input now has a different type. But we know that the context in the input is a request, and we can close that. Cool. Is that enough? No. It doesn't have a response writer. That's correct. That now lives in input.ctx. And down here, is that enough? Too many arguments in call to serve content. Which serve content did I get wrong? Aha. Thank you. Live coding is fun. And it builds correctly. Okay, so now, one more time. I'm just going to go over here and see if I didn't leave any more servers running. Oh, yep, no, there it is. Kill that one. Okay, now we can run. Okay, now it's running. And so the behavior we should expect to see is on our first request, it should take some number of milliseconds to produce the Mandelbrot and serve it. And on subsequent requests, it should be faster. So I'm going to pull up inspect right now. And this, here it is. So there's the Google search page, but I'm going to go to network. Network's going to show us how long it takes in this little waterfall view in the bottom right. So let's go localhost 8765. Okay, Mandelbrot, 69 milliseconds. Okay, and the content downloaded was 66. All right, seems fair. And if we hard refresh that, oh, what's going on? 16 milliseconds. Okay, a little bit better. Content download only 12.84. We could repeat this process a bit and see how it behaves. But can we do better? Well, yeah, we can actually. So the nice thing about building a program in this way is the structure is fairly obvious, and so, and by that I mean we can we can try and understand bits of the program in a programmatic way. So I'm going to delete this channel and I'm going to stick some other stuff in. Sensibconfig is now going to use a HTTP server mux. That's going to go in there. They're already compatible. And this thing just takes a collection of routes. So we have one that's built in called route, and I'm going to add another one called metrics. And some of you may see where this is going. Yep, and then there's a comma there because it's JSON. And if I tick this box, cool, so we have route there. And now we just need something to handle the metrics route. So let's create a Prometheus metrics handler that already understands what comes out of a /metrics request and knows how to serve it. And that's all the configuration there is for that one. So cool, so now if I just save and run that. Yep, it's going. Okay, so if we, oh, hang on. Let's go to here. So the Mandelbrot still goes, and if we go /metrics, we get, is it working? Oh, damn it. You know, I should really learn. Okay. Okay, running, cool. Hey, we see a bunch of metrics, a bunch of Prometheus metrics ready to be picked up. And I already have an instance of Prometheus running, which is pointed at that port. So we can, oh, hang on. So unfortunately, they're using my other example of that. But if I just refresh this one, I'm going to, I'm just going to go to the bottom and add a new graph. So we have some metrics about the cache, which is cool. We have requests in, requests out. And if I, what's it doing? Oh, yeah. Yeah. Oh, very funny. And should still, no, we looked at the Mandelbrot before, so we still had 11. So we see that shortly after the server started, there were some requests. These requests coming into the servmux include the requests by Prometheus to the metrics handler. So that's always going to continually go up, and it's just going up slightly faster if we request the Mandelbrot. All right, so with that, I can, if I had more time, I would be able to get the data that would let me then, keep tuning the server and adding, chopping and changing bits and pieces and so on. But hopefully you get the idea. This is the sort of thing I'm thinking of when I think of visual programming and what I would choose to use if I was going to use a visual programming environment. Thank you. And I'd say we have time for one question. Kasky?
What about round trip, where, let's say you authored or generated a bunch of code, and then maybe tweak the generated code and you want to get it back into the...
That's...
a round trip through visual, generated code, tweak the generated code, and then go back to the environment. What would it take, you think, to make that happen?
That's definitely a stretch goal. I have a few things I'd like to resolve first, like automatically killing generated servers and making the experience a little bit better on the user side. But yeah, no, that's definitely something I'm looking at. It may involve a few carefully constructed comments in regular Go source. I don't like that very much. So, watch this space.
15 years ago with case tools, where you could do a bunch of visual design and generate a bunch of code, you couldn't round trip. You generate it, and then now you're stuck in regular coding land, and you couldn't go back to the tool without throwing away any mods that you made afterward.
Yeah. So what Kasky said, basically, with old tools as well, you can't round trip the source code. And you're basically stuck with the generated output from that point onwards. That is, yeah, I agree, that's definitely a downside. You do at least get to keep the code that you generated. And hopefully you kept the source so you can then generate it later on. But yeah, no, I agree. At this stage, it was more preparation for this talk than I was about to do.
once you started then actually trying to finalize the product, you couldn't go back to those tools to do anything without throwing away all of the incremental work you'd added in.
Yeah.
That whole round trip back to
You can't.
the tool.
Yeah, you can't. If you can't take the code back, you can't preserve your incremental changes to the output source code. Yeah. No, I agree. I agree completely. Yeah.
It's not a criticism of your solution. It's just in general, this problem space has that.
You. Yeah, so this comment was LabVIEW doesn't generate source code, it just has a single view and you don't get access to that. And that's fine, but I like tinkering under the hood. You know, a regular Go compiler produces assembly, which produces machine code, and so you could theoretically tinker with that. All right, thank you.